Hey guys, welcome to another video. So here we will be trying to attempt to solve the length of a specific side, in this case BD, which I'm going to call X right now, using a two triangle problem. Okay, let's have a look. So one thing you want to notice is that in order to get the length BD, we only have pretty much one information, which is 51 degrees. We cannot solve this without finding a length for, say, DC. And frankly, for length DC, we can call it Y for now. It is actually possible because we have enough details in order to solve it. I'll show you why. Also, another major point to point out is that when you want to work out any triangle, firstly see if you can calculate all the angles. And if so, yes you can. So looking at this line here, so we can see at this line, we know that for a straight line, all angles must add up to 180 degrees. So we can easily compute this. So 51 plus a certain value will equal 180. So subtracting will give us 129. Good. Now, let's just work with this triangle here. How can we get the value of y? Well, we can either try the sine rule or cosine rule. I'm going to put my money on sine rule because why? We have two angles and we have two lengths. We can do it practically. So using the sine rule, we know that the method is always going to be the length over the sine opposite that length, which will always equal another length over the sine of that length. So let's just call it A over sine B. A, capital A, equals small length B over sine capital B. Our small a in this case could be y over a capital angle 32, so sine 32. And this is going to equal another length, which we have is 47. And this is going to be over sine 129. So remember, this is to do with the first triangle. So I'm going to put this for this triangle here. Okay, for the very first triangle, triangle ACD. Okay, let me just draw a mini diagram next to it to make it clear. So triangle ACD. Okay, perfect. So ACD, hold on, just swapping pens. So ACD. All right, so now, so let's go back to the question. So let's calculate the value y. So to find the value y, we need to isolate it from sine 32. So to get rid of it, we need to multiply both sides by sine 32. And when you're doing that, you should get y equals 47 over sine 129 times sine 32. And evaluating this in your calculator, you should get exactly, or roughly, 32.0 to three single figures, meters. Now, since we found the value y, how about we redraw another triangle with this right angle triangle, yeah? So just to make it life a lot easier. So I'm going to draw one here again, so triangle DCB. So this two-step problem, what do we have now? So here we have the angle of 51 degrees here. We've got a length of x, we don't know, but we know y is now 32.0. Yeah, just 32 is fine. Okay, so how are we going to solve this? So let's have a look. So hold on, let me just make this, get rid of the shape. Format, hold on. There we go. Just like to work it, make it look a bit nicer. Okay, so the only way to work this out, we can use trigonometry here. So we're going to use trig. Okay, so this one was sine rule, just to recall, yeah, sine rule. So this here was sine rule, this is trig. Now, how do we remember this? So we know for trigonometry, the angle opposite, the length is always known as the opposite based on this angle. So this would be the op, but then therefore x must be the adjacent. So let's call x adjacent, and this leaves us with 32 being the hypotenuse. Hypotenuse. And recalling SOHCAHTOA, so we got SOHCAHTOA. We need to see what works. And looking at it carefully, we got A and H, so clearly Ka would be the one. So therefore, this tells us that we're going to use cos equals adjacent of hypotenuse. So cos, the angle which is 51, equals adjacent x over hypotenuse 32. And therefore, multiplying both sides by 32, we're going to have x equals 32 times cos 51. And this should give us about 20.1 meters. And that's it, guys.